Hi, good evening to all of my Open University friends. Today I am sharing my knowledge in the activity 22.2.7, that is page number 142. That question is, prove the series sigma 1 to infinity sin n over n is convergent. Here I apply the method of Dirichlet's test. Here, first you need to read the proof of that theorem. That is lie on the page number 139. I am reading the test. I am reading the Dirichlet's test theorem. First, let an be a series with bounded partial sum. Let bn be a decreasing sequence of positive term which converges to 0. Then the series n equal to 1 to infinity an into bn convergent. This is a theorem. So here two things are very important. First is bounded partial sum. Which I consider the sequence is bounded, which I consider the series of sigma an is bounded partial sum, and I consider the another sequence decreasing with positive term n converges to 0. So our question is modification. I consider n equal to sigma n equal to 1 to infinity an, that is sigma n equal to 1 to infinity sin n. And I consider the bn sequence is sequence 1 over n. This is the 2 is. I want to prove by theorem. By theorem I want to prove this is positive sequence and decreasing and converges to 0. I want to prove these three. And also I want to prove sigma n equal to 1 to n an equal to bounded partial sum. So I need to prove those three things. So let's consider first I consider the sequence of bn, that is 1 over n. We know for all natural number n greater than n plus 1, n also n comma n plus 1 also greater than 0. So I can rearrange this format. To this is, and also 1 over n comma 1 over n plus 1 also greater than 0. This is the bn plus 1. This is our bn. So our sequence is decreasing. Also with positive term. Now I am moving on. That is converges to 0. So our sequence 1 over n minus 1. So by Archimedean property, our sequence bn, that is 1 over n, converges to 0. So I prove those three things. What thing? Our first page, our sequence bn, that is positive term and also decreasing, also converges to 0. So I am moving to our series of this partial sum are bounded. So I consider first observe this format 2 sin 1 into sin n, that is our trigonometry rules cos n minus 1 minus cos n plus 1. We know by A level. So our partial sum format is sigma 1 n sum n equal 1 to n sin n, that is sigma n equal to 1 to n bracket of cosine n minus 1 minus cosine n plus 1 divided by 2 sin 1, that is 2 sin 1, that is here multiplied by 2 sin n. So this 2, so I divided by 2 sin 1. This is the format of the partial sum of that series. Now I want to prove this is a bounded partial sum. So let's move on. Now apply n equal to 1 to m. All that is natural numbers. I want to consider that is bounded partial sum. So I consider the modulus of that partial sum formula. So that is this format, that is this format. So I can move on. Expand sum of terms. So expand sum of term, you can look like this: cosine 0 minus cosine 2 plus cosine 1 minus cosine 3 plus cosine 4 plus cosine 4, that minus n whole term to lastly cosine m minus 1 cosine m plus cosine m plus m minus 1 minus cosine m plus 1. This format look like on. So first you read all expanding term very carefully, very long term in your paper, then analyze which term are neglecting, which terms are neglecting. Clearly observe second term neglect, then third term always not neglect, then fourth term, fifth term, sixth term up to m minus 1 term, then m term not neglect, m minus 1 term neglect, then m minus m plus 1 term are that is on. So first write this format in your paper, expand, and then observe that. So clearly our result in cos 0, cos 1, cos m minus 1, cos m plus 1 are balanced. So we know modulus of cos 0 less than or equal to 1, modulus of cos 1 less than or equal to 1, modulus of cos m less than or equal to 1, modulus of cos m plus 1 less than or equal to 1. So our whole formula less than or equal to 4 divided by modulus of 4 divided by 2 sine 1, that is 2 over sine 1, and now I put that is equal to m. That is equal to m. That is, there is a natural, there is a real number. I don't know. That's a natural number. So we know our partial sum formula. Here I write this is our partial sum formula. M n. Our partial sum formula is bounded. I proved. So now move on the first page. I proved that partial sum formula is bounded. So I also earlier proved sequence of Bn is positive term with decreasing converges to 0, and also proved partial sum formula is bounded. So our Dirichlet test, our question series, that is conversion. This is my idea of that activity. If you find any fault, please comment below, and also please subscribe for helping me. Thanks all friend.